Hello, statistics and pre-calculus. Welcome to your next video on 12.1, in which we're going to go over a few examples of arithmetic sequences, and then you can kind of work through the rest of the worksheet on your own. So we're just going to jump right into it. If you need a refresher on an overview of arithmetic sequences, please check out the previous video, which we did, where we did that. Otherwise, let's just jump right in. So we have got 3 examples to go through here. So our first example just asks us to determine whether each sequence A and B are arithmetic, and if they are, we need to give our formulas for it. So the first thing we need to do is identify whether or not the sequence is arithmetic. So we're either going to put a big A or a big NA here. So this first sequence, when we're asking ourselves, is it arithmetic, what we're really asking is, of course, am I going to get the next term of the sequence by adding or subtracting a constant number? So I go from 17 to 16.5 to 16 to 15.5, etc. So it looks like what I'm doing is subtracting 0.5 each time. That means that this is an arithmetic sequence. On the other hand, when I look at this guy, I go 20 to 10 to 5. So the difference between 20 and 10 is 10, but the difference between 10 and 5 is 5. So we're definitely not adding or subtracting a common number just from those first 2 terms. I don't even need to go any further because this is not arithmetic, right? So now we're going to get into writing our formulas for the one that is. So again, we said that we were subtracting 0.5 every time. That means our common difference, or D, equals negative 0.5. So this is really all we need to write our formulas. So an explicit formula is going to be of the form A of n equals A of 1 plus D times n minus 1. So in this case, we have A of n equals A of 1. Remember that A of 1 is your first term, which is 17, plus D, our common difference, times n minus 1. Now we might want to write this a little prettier and just say 17 minus 0.5 times n minus 1. Our recursive formula is the one that's a little more complicated because it has 2 parts. The first part is to write out your first term. We've already decided that A of 1 equals 17. And then we say A of n equals A of n minus 1 plus D. So in this case, A of n equals A of n minus 1 plus D. D is again negative 0.5, so minus 0.5. So this is recursive. So both parts here are our recursive formula. And this guy here, just this guy, is our explicit. So in the second one, if you're wondering, what we're actually doing here instead of adding or subtracting by a constant number is dividing. So notice here that we go from 20 to 10, so we divided by 2, from 10 to 5, divided by 2 again, and so on and so forth. So this is actually what we call a geometric sequence, which we will be discussing in our next set of videos. So that is a little preview there. Now, second example, we got a little bit more complication now. So we're actually just given a series in explicit form, and we're told that we need to find the first 4 terms. So how do we do that? Well, one way we can do that is by plugging in n equals 1, 2, 3, and 4 into this formula here. Remember that the explicit formula basically gives us each series of the term based on the term number. So since we want to find the first 4 terms, we want to find terms 1, 2, 3, and 4. We can plug in 1, 2, 3, and 4 for n to find our numbers. Now, we can do that. Might take a little long. Another way we can do it is simply say, wait, what are my 2 parts of explicit formulas? My first part is I have to know A of 1, the first term, which in this case is 17. And I have to know my common difference, the thing I'm either adding or subtracting, which in this case is 3. From these 2 things, I can actually tell what my first 4 terms are going to be. Of course, this means the first term is going to be 17. Each successive term is just going to be 3 plus the previous term. So 17 plus 3 is 20, 20 plus 3 is 23, and 23 plus 3 is 26. Now, if you wanted to do a quick check, maybe we will just find the 4th term using the formula to make sure we got it right. So A of 4 for the 4th term equals 17 plus 3 times 4 minus 1. Here we've got 4 minus 1 becomes 3. 3 times 3 is 9. 9 plus 17 is 26. We are all good there. Now, second part tells us, let's write the recursive formula for this sequence. So again, we have all of our pieces. We've already done this up here. Take a few minutes, pause the video, see if you can do it on your own. If you are ready, come back. I will write the answer for you. So the recursive formula is a of 1 equals 17. A of n equals a of n minus 1 plus 3. Hopefully you all got that. If you didn't, you might want to go back and rewatch the earlier videos, check your notes, etc. All right, we're moving along. Find the 99th term. Now remember, what did we just say? N is our term number. So whatever term we want to find in this sequence, we just substitute for n. So in this case, it's telling us that our n equals 99. So I'm going to take a of 99. So a of 99 equals 17 plus 3 times 99 minus 1. Go ahead and do that in your head or on your calculator really quickly. I've already done it. The answer is, press pause if you don't want a spoiler, 311. All right, last two ones. They require a little bit more thinking. So how would we tell if a number is the term of the sequence? So remember that a of whatever, a of n, is our sequence, as is the number in the sequence. So if 1,000 is the term in the sequence, this formula at some point is going to equal 1,000. For some n, 17 plus 3 times n minus 1 is going to equal 1,000. So what we do is set 1,000 equal to 17 plus 3 times n minus 1. If this comes out to a whole number, we know that 1,000 is a term of the sequence, and 2, that whole number equal to n, is the term. So first step, we want to isolate this guy. We're going to bring negative 17 over to the other side. So we're left with 983 equals, and let's just go ahead and factor this out, 3n minus 3. Again, we're going to add 3 here, get 986 equals 3n. And when you divide 986 by 3, you get a repeating decimal. It is not a nice whole number. That means that 1,000 is not a term in the sequence. So let's do it again for 2,000. We set 2,000 equal to 17 plus, let's just go ahead and factor it out, 3n minus 3. So add 7 or subtract 17, add 3. So first we subtract 17, we should get 1,983. Then we add 3, so we get 1,986 equals 3n. And what do you know? If you divide this guy by 3, it is a nice whole number, and that whole number is 662. That means that, yes, this is a term, 2,000 is a term, and the term is 662. So 2,000 is the 662nd number in this sequence here. Awesome. Hope everybody's feeling good. Feel free to go back, rewatch any part of this video if you want to. We're going to move on to the very last one, which simply asks us to fill in the blanks to complete these sequences. So we're given that they're arithmetic, so we know that the trend is just going to be adding or subtracting some constant number. Now in this first case, we are given two numbers that are spaced out, right? So what we need to do is we say we have a 12, and then we go 1, 2, 3 spots to get to 33. So to find our d, our common difference, the number that we're adding or subtracting, in this case I hope you notice that we're going to be adding because 33 is bigger than 12, we're going to take 33, subtract 12 from it, and divide by the number of spaces between. So again, we said that to get from 12 to 33, we go 1, 2, 3 moves. We're going to divide by 3. So 33 minus 12 divided by 3 is actually a whole nice number of 7. So this is our d. Now all we have to do is add 7 to each term. So 12 plus 7 is 19. That's going to give us term number 2. 19 plus 7 is 26. And here's your check step. Does 26 plus 7 give us 33? It does. So we got that one right. And then 33 plus 7 is 4D. Alrighty. So the second one, you can do it a little bit differently. See if you can figure out how you would do it. Press pause. I'm going to go ahead and go right through the answer. So once again, what we're going to do is say we went from 92 to 89. I need to figure out how I got there. So to go from 92 to 89, I just went one step. So I'm going to take 89, subtract from 92, and divide by the number of steps, which in this case was 1. So 89 minus 92 is -3. So that is our D. So now we can kind of just work backwards. If this is the last part of our sequence, we're going to be adding up to get further back since our D is negative. So 92 plus 3 is 95. Quick check here, 95 minus 3 is 92, so this is correct, right? 95 plus 3 is 98. 98 plus 3 is 101. 101 plus 3 is 104. All right, that wraps up the 12-1 of arithmetic sequences video. I will see you in your next video series.